Hello everyone, I am Gajanan Pradhan, one of the ESRs of the BeMAGIC consortium. I have been working at INRIM, which is the National Institute of Meteorological Research in Torino, under the supervision of Professor Paola Tibarto. And I also got my PhD degree this year from the University of Torino. The main objectives of my project was the use of electric fields to control magnetization in nanostructures and microstructures for low power magnetoelectrics. And the major goals were this characterization and fabrication of iron gallium films and microstructures, and understanding the effect of strain via different ways, mostly through these electric field effects via domain wall structures and hysteresis comparisons. There have been some proposed models for this electric field usage in the devices related to the magneto-resistive RAMs, and some of them were mentioned here on the left, where people have proposed the use of piezoelectric layers with magnetic layers as a substitute to induce the change in magnetic layer or the magnetism by applying the electric field across this PMNPT stack. In other devices, like the meso devices, they have used these bulk magnetoelectric layers where they have used electric field to induce the change in magnetization, which further changes the current output that we measure in these devices. In our work, we have used similar concepts. We have used a PMNPT layer, and on the top and bottom, we use some conductive pads like gold and silver. On top of that, we have fabricated the iron gallium discs, as you can see here, and we applied this electric field across this to change the domain structures of these discs. Further, we have planned to even fabricate these gold pads and use these gate structures with others kind of uses to locally control each of the dots by applying programmable switching factors between these lines. A brief summary of the research work we performed. At start, we focused on the effect, studying the effect of strains by depositing these iron gallium films on flexible substrates, and we could see the change of magnetization via hysteresis curves. And then the second part, we deposited similar films on PMNPT substrates, and we applied electric field as shown here to understand the amount of strain we are generating. So based on the strain as shown here, the compressive and the tensile strains, we could understand the hysteresis via different magnetometers measurements. And also the domain structures were very different at different kind of electric fields applied. Moreover, we could also achieve the cyclable magnetization changes as a function of electric field. Further, we also prepared these iron gallium discs structures and understand to understand the magnetic structures we are forming. So as we can see here, we generated these double vortex and single vortex states in these kind of systems. And these are the publications related to these works. The BeMAGIC project addresses three major environmental concerns, and one of them is towards the energy efficient memory devices. As we know, all the current generation memory devices are used by currents, which has Joule effects. So we have a lot of energy usage, and then we have more energy losses. And to suffice those energy losses, we use again cooling devices, which again increases the costs. So a possible solution is to use the electric field, which have shown to reduce the energy needed to cycle the magnetization in the materials. And if we achieve these concrete electric field switching behaviors, then we will be leading to huge or significant energy savings with important cost reductions, and possibly reduce electricity bills that we incur. Some other aspects of magnetoelectrics are also the exploration of new materials or alloys or these combinations to form these artificial multiferroics. These can be used in different spintronic and magnetic devices. Moreover, these can also be used, these combinations of core cells, for use in biomedical applications. The major benefits from the ITN was the first one is the academic and industrial network that we have. I had this chance of doing the secondments at a company, NTTS, and this institution at CTAC, which gave me different insights about the working culture and the methodologies. The network meetings that were intended for the training of ESRs that helped us to plan plan the activities and also the requirements for the PhDs and objectives of the projects. Next is the meeting with renowned scientific professors and other members of the community that help us create good collaborations in the field of research. Further, I attended different schools and conferences in these 3 years where I could go to international and national conferences where we learn a lot about the different aspects of magnetism or similar to what field we work on. The schools they help us to meet with different young people or aspiring researchers like ourselves, and they definitely will for help. It will help in future to make good collaborations. Next is the scientific publications that we do in international journals. They definitely give ourselves different good recognition in the community. And the research skills and techniques on all these 3 years, I learned a lot on the experimental techniques and the simulation techniques, and also I helped in developing some new different techniques for fast and good measurements. Next, and the last is the research management and transferable skills, where there have been specific trainings in the BeMAGIC consortium that gave us ideas about this project management, resource management, working as a team leading, and etc. I enjoyed, as a whole, overall, working as a PhD student, and with all my expertise that I gained in these years, I have now planned to continue my career as a researcher. And in the future years, the position can be anywhere, like in a research institution or a company, and depends on the job satisfaction and working culture. Thank you very much.